Hello dear students. Let us solve few more problems related to Nernst equation and electrochemistry. The next question that we are going to solve is again related to the Nernst equation. It says that write Nernst equation and calculate the EMF of the following cells at 298 Kelvin. Sn solid oblique Sn plus 2 salt breeze. The concentration of Sn plus 2 is 0.05 molar. The salt breeze H plus, the concentration is 0.02 molar H2 oblique Pt. So, my dear students, we want to solve this. We want to write the Nernst equation for this. Here, from the representation of cell only, this is the anode and this is cathode. So, anode oxidation takes place. So, Sn, that is tin solid, converted into Sn plus 2 and 2 electron. My dear students, you can see that 2 electrons are added here into 2H plus, so total N is equal to 2. That is what we can say. In cathodic reaction, 2H plus gets 2 electron to convert itself into hydrogen gas. Cell reaction takes place as Sn, that 2H plus, it gives Sn plus 2 plus H2 gas. So this is overall reaction. Here N is equal to 2, and we write E cell is equal to E0 cell minus 0.0591 by 2 log of oxidation divided by reduction. So oxidation takes place for Sn and reduction takes place for hydrogen. So we'll write the concentration of Sn plus 2 and concentration of H plus 2. As it is the stoichiometric coefficient, so we need to put the power 2 here. This stoichiometric coefficient goes into the power. Now we know that the concentration of Sn plus 2 is 0.05 molar and concentration of H plus is 0.02 molar. So uh, ultimately we put these values into this equation, and E0 Sn oblique Sn, like E0 Sn is 0.0. Standard electrode potential for tin is 0.14. Standard electrode potential for hydrogen or standard hydrogen electrode is 0.0. So we can write for reduction we can write minus 0.14. For oxidation we can write 0. Sorry, for reduction we can write 0.0, and for oxidation we can write minus 0.14, and then we put the value of the tin concentration 0.05 and hydrogen concentration is 0.02 square. So this tin concentration 0.05 and hydrogen concentration is 0.02 multiplied by 0.02, that is 4 into 10 to the power minus 4, and this is 4 into 10 to the power minus 2. This simply turns into 0.14, and by dividing 0.591 with 2 we get 0.02955. Now we'll divide this. 10 to the power minus 4 goes up and it turns into 10 to the power 2, and this 5 divided by 4 gives you 1.25, but as it is 10 to the power 2 multiplied we get 125, and we will see the log of 125. When we take the log of 125 we get it 2.0969. Here we already have 0.14, so by multiplication we get 0.062, and the final answer we get is 0.078, which is approximated to 0.08 volt. Now we look at the another cell representation, which is PtBr2 oblique Br minus salt bridge H plus 0.03 molar oblique H2PT. So again we have standard hydrogen electrode bonded with bromine cell which is having platinum inert electrode. From the above reaction we can simply come to know that Br minus has converted to Br2, so it's oxidation. Your H plus ion are converted to H2, so this is reduction. Both this reaction 2 electrons are exchanged, so we can write N is equal to 2. The overall reaction is 2 Br minus plus 2 H plus, it gives Br2 plus H2. Now if we consider this equation as an equilibrium equation, then for K we write Br2 liquid and H2 solid divided concentration of Br2 concentration of H2 divided by concentration of Br minus and concentration of H plus. As the concentration of Br2 liquid is unity, as the concentration of H2 gas is unity, That means we put 1 and 1 for this, and for this too we will have to write the concentration. Let me write it for you. If this reaction is like, if there is a equilibrium here, we will write the concentration of Br2 liquid divided by concentration of H2 gas, and then you have divided by concentration of H plus, that is whole square, because 2 is the stoichiometric coefficient and 2 is the stoichiometric coefficient for Br also, so we'll write Br minus to the power 2. The same we can write it for here, so it is 1 divided by H plus. So now when we write the Nernst equation, E cell is equal to E0 cell minus 0.0592 by 2 log of 1 divided by, this is 1 here, 1 divided by H plus concentration square and Br minus concentration square. For E0 cell we can write E0 reduction minus E0 oxidation, and for H plus concentration we can write 0.03, and for Br minus concentration we can write 0.01. See, the concentration are given here in the question, 0.03 and 0.01. So we'll write it that way, and then by putting the values for reduction we will have the hydrogen shell as for oxidation we have bromine shell. These values are multiplied with each other. 3 multiplied by 1 will give you 3, and then 1, and this is like, this is 10 to the power minus 2, this is 10 to the power minus 2, square turns into 10 to the power minus 4, and the total square is there, like both the value have these squares, so we'll write square over there. By putting the value of standard hydrogen electrode and Br minus, that is 1.08, we get minus 1.08, and then this 0.0592 divided by 2 will give you 0.0295. This is what it is, nothing but log of 1 by 3 and 10 to the power 8. Log of 1 by 3, it gives us 0.111, and total 10 to the power minus 8, when goes up it turns into 10 to the power 8. So we'll write log of 1.11 into 10 to the power 7. So log of 1.11 into 10 to the power 7 is equal to log of 1.11 plus log of 10 to the power 7. Log of 10 to the power 7 is 7, and log of 1.11 is 0.0453. By doing this addition we can 7.0453. This 7.0453 multiplied by with 0.0295, and we get 0.208, and then by doing the subtraction we get minus 1.288 volt. This is negative value, that means this particular cell is not feasible and it does not work. So to make this cell work, we will have to invert the position of both the half cell. So if hydrogen shell is made as anode and bromine shell is made as a cathode, we can get plus 1.288 volt, and then this reaction will be feasible. This is very important question, and it is asked many a time into the board exam. Please learn it well. Then we have one more question, few more questions to solve. Let us look into this. The cell in which the following reaction takes place: 2Fe plus 3 plus 2I minus, it gives 2Fe plus 2 plus I2 solid, has E0 cell is equal to 0.236 volt, and temperature is 298 Kelvin. Calculate the standard Gibbs energy and equilibrium constant for the reaction. Here we need to find out delta G and K. They already given the E0 cell, that is 0.236. So when we look at the reaction, Fe plus 3 is converted to Fe plus 2, so 1 electron. 2I minus are converted to I2, so here it is 2 electron, and that is why Fe is multiplied by 2, so N is equal to 2 here. We know that the equation delta G0 is equal to minus N Fe cell. So just by putting the value, N is equal to 2, F is equal to 96500, and E0 cell is 0.236, we get final answer delta G0 is equal to minus 45.458 kilojoule per mole. By putting, like, if we want to find out delta G, but we know that delta G0 is equal to minus RT, L and K, we want to find out K. So by putting the value of R is 2. Or we can write minus 2.303 RT log K. So minus 45.548 is equal to minus 2.303 multiplied by 81314 into 298 log of K. Therefore log of K is equal to this value divided by all these values. And finally we get log of K is equal to 7.983. We know therefore K is equal to antilog of 7.983. Antilog of 7, that is 10 to the power 7, and log of 0.983. Antilog of 0.983 is 9.62. Then we have one more question, my dear students. In the button cell, button cell which you might have seen in your wristwatch or somewhere around, this button cell has oxide zinc and silver oxide cell. So it used the zinc and silver oxide as reactants, widely used in the watches and the hearing aids. The following reaction takes place, my dear students. Just pay attention here. Zinc, this Ag2O, that means this is nothing but your Ag plus 1, that is 2. It reacts with water and gives us the Zn plus 2, 2Ag solid and 2OH minus. You can see that zinc is oxidized and 2Ag plus is reduced to Ag. Determine the delta Z0 and E0 cell for the reaction. We just need to find out the delta Z0. For finding out the delta Z0, we can use either the equation minus NFE or RT ln K, and for E0 cell we can use the Nernst equation. So first we have written the equation the same as this. Here on at anode oxidation takes place, so zinc is converted to Zn plus 2 and 2 electron. 2 electron are again passed to Ag2O and 2 and H2O, so that we can get 2 Ag solid and 2 OH minus. Here N is equal to 2. We have the Nernst equation. E0 cell is we have equation E0 cell is equal to E0 reduction minus E0 oxidation. So E0 reduction is your reduction of silver and oxidation is of zinc. So we write 0.080 minus 0.76, and finally we get 1.56 volt. Now delta Z0 is equal to minus NF E0 cell. N is equal to 2, F is 96500, and E0 cell is 1.56, and finally we get the value as 301.08 kilojoule per mole. But when you will study the button cell, you will come to know that it produces the voltage of 1.1 volt. So by calculating here we get 1.56 volt. If we want to get 1.1 volt, actually the standard cell electrode for E0 Ag2O oblique Ag should be taken as 0.344. If we take this E0 Ag2O oblique Ag as 0.344 instead of this value 0.80, if we write here 0.344, then the value of E0 cell we get is 1.1 volt, and then by calculating delta G we get the value 231.072 kilojoule. So this is how, my dear students, we can solve all the problems. Please learn these problems and they will help you a lot. Thank you.